there's an alternate description of a black hole in terms of what's known as the holographic description. It's as if there's a two-dimensional world that surrounds any given three-dimensional world that has exactly the same physics as the three-dimensional world that we're familiar with, and yet it describes it in a completely different language.
I think the term black hole is very self-explanatory. We have no single clue on what is on the other side of that deep, dark mystery. But did a new answer finally arise to satisfy our curiosity of black holes? We know that extreme gravity traps objects in space so tightly that not even light can escape. The black hole's tidal forces would spaghettify you long before you pass the event horizon, the point of no return. Despite this one-way trip, what happens within a black hole was just recently revealed by scientists. The concept of a black hole may be broken down into two distinct regions. The event horizon is the surface of the black hole, although it's really just the point at which the pull of gravity becomes too great for any object to survive. Then the singularity might be right in the middle. The definition of an infinitesimally tiny and endlessly dense point, the singularity at a black hole's core is the ultimate no man's land, a point at which matter is compressed to an infinitesimally small and all notions of time and space totally break down. It also doesn't exist in the actual world, but what if scientists finally figure it out? What if black holes were nothing more than holograms? A holographic reality might explain all the black holes we observe. At least it appears to be the starting point for a lot of the latest research in PRX quantum. The research investigates the inner workings of black holes in more detail than has been done before. The holographic duality hypothesis is a mathematical effort to unify the particle and interaction theories of general relativity. Despite how far-fetched it might appear, it's worth a look. At first, it might be hard to locate those voracious beings, despite the fact that the Milky Way contains more than 100 million black holes. The black hole Sagittarius A in the heart of the Milky Way is a supermassive object. In fact, it's so enormous that it has a mass of around 4 million times that of the Sun and is located approximately 26,000 light-years away from Earth. In 2019, scientists used the Event Horizon Telescope to acquire the very first photograph of a black hole. The black hole at the heart of the galaxy M87 has been studied in great depth thanks to the Event Horizon Telescope. We now know that photons are being consumed at a very high rate. The mechanics of black holes may provide astronomers with insights into mysteries that have escaped them so far. Two of the layers of the black hole are the event horizon and the horizon itself, while the third is the singularity. Once in the event horizon, no light can leave the vicinity. Once a particle crosses the event horizon, it disappears forever. The singularity is the very compact region of space-time where all of the mass of a black hole is concentrated. Astronomers, in order to identify a black hole in the pitch blackness of space, must rely on the radiation produced by black holes when they consume dust and gas. Since there is so much gas and dust surrounding these monster black holes at the center of galaxies, pinpointing their exact locations is very difficult, if not impossible. Many scientists have been intrigued by the possibility that black holes are responsible for the whole birth of a new universe, despite the fact that no one knows for sure. To a large extent, the cosmos is conducive to the growth of life. Because the black hole singularity violates our current understanding of physics, we may have to change our physics model altogether in order to fully understand it. Discoveries regarding black holes' interiors are made possible by quantum computing. In holographic duality, the equality of the standard model of relativity and the standard model of particles plays a pivotal role. And mathematically speaking too. There are several mathematical similarities between the theory of particles and the theory of gravity. Several different types of spatial settings may be defined using these notions. Particle physics simply need two spatial dimensions instead of the 3 dimensions needed by gravity. Scientists hoped that by breaking down this idea, they may get insights into the workings of black holes. Many are studying every day to focus on 2 possibilities. Only space-time and the void exist in Einstein's theory of general relativity. To paraphrase what he says, there's no gravity in the standard model of particle physics. To find a middle ground between the 2 schools of thought has been a human pursuit for over a century. Many renowned scientists studied the relationship between holography and quantum matrix models. Efforts were made to ensure that our knowledge of particle physics and general relativity complement each other rather than compete. Matrix models with both numeric and blank cells were employed for this purpose. It is a common practice for quantum computers to use one-dimensional strings to represent particle physics. As Rinaldi emphasizes, they often help create the ground state, which is essential for gaining useful insights. They extrapolated the interior structure of the strange objects using their concept of black hole gravity. How did we get here if not from a hologram of reality? When you hear the term hologram, what image first pops up in your head? According to the work of Rinaldi and colleagues, the term interior-exterior border refers to the transition zone between a black hole's inside and outside. According to general relativity, the black hole's interior becomes visible in 3 dimensions as space-time escapes from the hole. However, the black hole was not perfectly flat upon further observation. Due to the lack of 3D perception, it gives the impersonation of being holographic. This is because particle physics cannot be used in a 3rd dimension. Since this is how our world functions, it's possible that this works elsewhere. However, there's no current proof to back up such a claim. But there's a lot of evidence popping up everywhere in the universe, and sometimes scientists find the Holy Grail. As uncommon as finding a needle in the haystack is, astronomers have found a black hole in a neighboring galaxy. A dormant black hole that did not originate from the supernova explosion of a dead star has been found by researchers, making this find the cosmic equivalent of finding a needle in the haystack. The black hole has at least 9 times the mass of the Sun and is located 160 million light-years from Earth. It's impossible for even light to escape a black hole's tremendous gravity. This black hole is unique because it was not formed in a supernova, and because it does not produce excessive X-rays, indicating that it has swallowed everything in its area. The best part is that it's located in a galaxy that's very similar to our own, which begs the question, could it happen near home too? At least 9 times as massive as our Sun and located about 160,000 light-years away, the Tarantula Nebula is a planetary nebula in the Large Magellanic Cloud Galaxy. A light-year is the approximately 9.5 trillion kilometers that light travels in 1 year. A blue star with a mass roughly 25 times that of our Sun and the newly discovered black hole home make up the binary system VFTS 243. Scientists believe this secondary star will also collapse into a black hole, possibly merging with the first. Inactive black holes are difficult to detect because they interact so weakly with their environment, even though they're considered to be common. Members of the same team who found this option have disproved many others that have been offered before. Scientists have been hunting a rare black hole like this for decades. The Very Large Telescope at the European Southern University in Chile was used to evaluate data collected over a 6-year period. The classification of black holes is multifaceted. Stellar mass black holes, like the newly discovered one, are the smallest kind of black hole. They're created when enormous stars collapse and the conclusion of their lives. They are both moderately large and very big black holes in the centers of most galaxies. Despite their otherwise shiny exteriors, black holes are always shrouded in darkness. They are exclusively nocturnal and do not emit any light on their own. To this end, binary systems are often examined in the hunt for black holes, in which one very bright star orbits another, less visible object. It's often believed that supernova accompany the collapse of large stars into black holes. A star with a mass of around 20 times that of the Sun would shed apart its mass and then collapse in on itself without exploding in the stellar death scenario. The orbit of the system is practically completely round. The freshly produced black hole's orbit would have been elliptical rather than circular, because of the supernova's propulsion in an arbitrary direction. In that, it devours any gas, dust, or star that happens to stray into its area, mercilessly hungry. They're so strong that they can tear apart stars, making them some of the most destructive things in the cosmos. Their hidden weapon is gravity. If you can compress a lot of mass into a little area, your gravitational pull will increase accordingly. A black hole is formed when an object of sufficient mass collapses to a point that no light can escape. All that material, equivalent to millions or billions of suns compressed into such a small location, is what gives black holes their enormous gravitational force. For their hunger to be really insatiable, black holes must be able to scavenge nearby matter, which can typically identify whether a star is an accreting material from a partner star. The companion in so-called inactive black hole systems is so far away from the black hole that nothing can be pulled into the black hole and heated to the point where it emits X-rays. Instead, it's swallowed whole by it in an instant. In the constellation Centaurus, astronomers have found the brightest black hole in the last 9 billion years. Astronomers from around the world, led by several Aussies, managed to find the old black hole. Compare that to the one at the heart of our Milky Way galaxy, you'll see that this one is over 500 times smaller. Understanding the origins and evolutions of galaxies, including our own, may be gleaned from this brilliant object. They determined that the newly found monster in the last billion years was the fastest growing and brightest of the past 9 billion years by comparing it to other dazzling objects. A brilliant celestial creature, Centaurus may be found in the constellation of the same name. The black hole at the heart of our galaxy is a gigantic spherical object, but this one is around 500 times bigger. Since the 1960s, scientists have been looking for a black hole like this. What could be waiting for us inside a black hole? Tell us in the comments, like the video, and subscribe to get more like it.